AI spins up a new Go service and you have no idea how it works. Or you are jumping between microservices that all do things differently. Either way, you are stuck. Hi there, my name is Eugene and this is Crafted Bytes. Today I am gonna show you my template that changed how I build and structure Go services and keep them AI friendly. Here is what I mean. You ask your AI agent to spin up a new Go service. You wait for a few moments and then you see it generated something. Config, database, Docker, and typical stuff. It may seem pretty complete at glance, but then when you start working with it, you will quickly find many pieces that are missing. And you have two options now. You can improve your prompt and regenerate again. And you will probably have to do it multiple times. And burn a whole lot of tokens on it as well. Another option, you can obviously refine the code base and add missing parts yourself. Or you can do it with AI as well, but you will probably burn more tokens in the end. And if you are working in an org with multiple services, where everyone is different patterns, different testing strategies, different deployments, and stuff like that, then jumping between services becomes a context-switching nightmare. You are probably gonna be spending hours just figuring out how things are working in this one. And then, if you are back in few months, same story repeats. Today, I am showing you a template that solves both problems. And more importantly, I will explain why it is structured the way it is. We will cover pragmatic layered architecture, mapper tags, and where it makes sense paying it. What makes the codebase AI friendly? Production essentials. And testing strategies. And I'll be honest about trade-offs. This is not a silver bullet that will magically solve all the issues. This is rather a starting point, a foundation, and nothing more. At school, you may learn various architecture styles, like clean, hexagonal, onion, with all the layers, all the abstractions, how you build them, and why you need them. And then you start working with Go, and community tells you, start simple, don't over-engineer, don't use frameworks, stick to just stdlib. And now you are stuck between two pieces of advice. Follow the school advice too literally, and very soon you will get like 50 files to just save the user. You will typically see stuff like user DTO, user domain, user entity, user DAO. And of course you will have mappers everywhere, because you have 4 layers and you have strict boundaries between them. On the other hand, if you follow start simple advice too literally, few months in, and you can't test anything. Most of your tests are integrational, and you have to spin up the whole system and do some complex data prep to just cover some new edge case. And usually, such tests they tend to become flaky over time and somewhat challenging to maintain. Here is what academic papers, books, or forums tell you about all architecture styles. Hexagonal, onion, clean, they all share the same core idea. Isolate business logic from varying infrastructure. But here's the reality check. How often do you actually swap the database? And the answer is probably never. So the question becomes, how much of the abstractions do you actually need? And the answer I landed on: dependency inversion for testability, not swappability. I want to mock my repository in tests, and that's it. And here is the thing about AI. It doesn't need simple code bases. It needs comprehensible code bases. A well-organized structure helps AI to deliver much better results than a simple and flat code base. So, the structure and examples are the context. Let me show you what this looks like in practice. I've been using and refining this template over the past year, and I want to walk you through the patterns that make it work. I'll start with architecture and trade-offs I made. This is usually the part where most debates are happening. The template uses three-layered structure: API, application, infrastructure. Notice there are two different arrow types. First, the uses arrow. This is the runtime call. API calls the app calls infrastructure, top to bottom. Now, the import arrows. Both API and infrastructure import the app layer. The app layer is a central part. This is the key inside, inward dependency flow towards the app. This might look like hexagonal architecture, and if you only consider dependency flow, sure, but I wouldn't consider it hexagonal. I am not attempting to isolate the core. Inward dependency flow is mostly for testability and to minimize the risk of circular dependencies. I am not attempting to isolate the domain or gain some theoretical database swappability. Within the application layer, I prefer to split the code on commands and queries. And if you heard CQRS, this may sound familiar to you. Event sourcing, multiple databases, queues, and stuff like that. Well, it's not what it is. Why do I split them then? Let's have a look. So, commands. This is the place where your database mutations are happening. And this becomes quite logic heavy. A lot of validation, business rules, and stuff like that. And because of that, I prefer to test commands with unit tests and mocks. It is just way easier to simulate some particular edge case. And let's look on queries. Queries are usually pretty simple. You have some SQL, you run it, and that's it. Not much is happening here. And for queries, I prefer integration tests with the real database. I feed it with some test data, run the query, and check the result. That's mostly it. So, the complexity of the code and different testing strategies. This drives the split of application layer on commands and queries. One more thing on testing. I prefer to avoid shared setup for unit tests. For integrational, yes, it's unavoidable. But for units, fully isolated test setup works the best. And this function is doing exactly that. It will create a fresh set of mocks for every test case. And then, when you run all tests, there is zero chance of state leakage between test cases. And I have to admit that the template could have more examples of full integrational tests with API, including database part. And I'm planning to fill this gap. There is actually one thing in this template that I kind of hate to talk about. This is a classic example of pass-through code, one of the most criticized parts of the clean architecture. And there is actually a pretty good reason for it to exist. So, unlike list users query, which is one-off, it's not reused anywhere. The get user by ID it's actually used in few places across the app. And because of that, it's defined on the infrastructure layer in a corresponding repository, and then reused. The rule is, if you have a query that is one-off and not reused anywhere, then you define it on application layer. But if you have a query that you need to reuse in few places across the app, then you define it on infrastructure layer in a corresponding repository, and then reuse. And if you need to expose this query from outside of the app, like on API layer for example, then pass-through has to happen. And I constantly have this mental battle with myself. My pragmatic engineering part says, just use repositories on an API layer, and that's it. However, Architect is constantly pushing this back. No, we should use repositories only within the app. An application is your integration point. And honestly, I don't know what the best answer here. Would love to hear your opinion in the comments. There is one more thing to discuss here. We now have SQL on multiple layers. Is it a problem? Well, it depends. Database change is not something that is happening very often. And for me, this pass-through situation is way more annoying. I can deal with SQL scattered a bit. Important is to communicate and agree this with your team, and then follow the rule. And this, by the way, is a good example of a rule that should go to your AGENTS.md file. Your AI agent will pick it up and follow very well. I already tested it multiple times, and it works. Let's also discuss one more thing that is often a source of debate: the mapper tags. Some people may say, well, here you are mapping your app types to API types and vice versa. And this is a valid concern. For API, I accept it. And here is why: security and contract isolation. I've seen password hashes, OAuth tokens, or similar private fields leak into API response just because someone forgets to add this little JSON tag over here. And this is a silent failure. No compiler warnings, your tests are green, and this data is in the response. And sometimes it can stay unnoticed for weeks, if not months. This is especially true in AI era. The amount of code we produce is exceeding our ability to review it carefully. And you may have to pray if another AI tool that you use for reviews will catch this issue. So, for me, separate API types and explicit mapping is a must-have. I accept mapper tags for higher security and confidence. Few more words on the API layer. Here, I prefer OpenAPI first approach and generate the code from the spec. You can do the other way around if you prefer so. Both ways are fine. Important is to keep the code and the spec in sync, and doing this manually is hardly the way to go. Both ways have trade-offs. You will get consistency, type safety, and no drift. On the other hand, you are locked to the tool's capabilities. Missing feature, and you have to extend the tool or find a workaround. And sometimes it can be pretty annoying to deal with issues like this. In this template, I use API-Gen, a tool I built to generate HTTP layer from the spec. I'll leave a link on it in the description. I actually built it a while back, just had no time to make it available for the public use. I built it because I always find something missing in existing tools. So I decided to build my own. And luckily, with AI, building such tools becomes easier. I have also experimented generating an API layer using AI prompts. It kind of works, but each time you run it, you will get slightly different output, especially if you are switching models. Also, when it grows, updating it becomes quite challenging and painful, and you will burn quite a lot of tokens on it. So, at this point, I am honestly not sure if this is the best way to go. In this template, I also include a prompt to generate HTTP client layer that kind of follows the same pattern, and I'll do a quick demo in few moments. So, the architecture philosophy. Dependency inversion, just for testability, not purity. Comments, they are for usually more complex writes. And queries are for reads. Layer boundaries, they are suggestions, not walls. And mapper tags at the API boundary for security and contract isolation. And someone may say, well, that's just a clean architecture with fewer files. And they'd be half right. The principles come from clean or hexagonal, but I treat them as guidelines, not strict rules. Clean architecture says your domain should be framework agnostic or database agnostic, but this template says, well, I'm building a Go HTTP service with a scale database. I keep interfaces for testability, not swappability. And if you do need to evolve towards to a full hexagonal or clean architecture later, well, the foundation is already there. Just harden the boundaries, distill the domain, and that's it. The structure supports it. The codebase includes multiple AGENTS.md files on various levels. For example, on root level, it includes some general explanation of the project, some typical scripts and commands, codebase structure, and stuff like that. And, for example, on internal level, it is a little bit more detailed on architecture, typical patterns, some common examples, and stuff like that. And I don't really want to spend too much time here. There are a lot of videos on YouTube or blog posts around agents.md files. And I'll be honest with you, I generated initial versions of agents.md files with AI, and then I am constantly refining them while I am working on the codebase. There is actually one more thing in agents.md that I'd like to mention. The task completion protocol. This has significantly changed the quality of AI-generated code for me. The code may still not always be logically correct, and ideally, you review it. But at least you will know that it compiles, tests are green, and no linting warnings. And it doesn't really matter if it's a complex prompt or a simple one-off, like refine this function. AI will always, or almost always, follow it. Think about us, humans, and how we onboard to a new code base. We usually start with documentation that is not very often up to date. And we also look for examples, like here is an existing controller, I'll follow this pattern to build a new one. And AI needs the same thing, but it's best to provide some hints for it. Agents.md is already a standard to help AI understand the codebase. Cursor, Claude, Gemini, Code, and many other AI agents already support it. And it's not just for AI, it's for humans too. It's funny that AI is kind of forcing us to keep the documentation up to date. Every production Go service, and not just Go, needs the same common stuff. Configuration, telemetry, graceful shutdown, structured login, profiling, Docker, Helm. And these aren't optional. Building this yourself means reinventing or copy-pasting from somewhere. AI can also generate this stuff, but it's best you understand this part a bit better. So keeping a standard setup makes more sense. On the last two, well, not every service will be deployed with Docker to Kubernetes, but these days this is pretty much a norm. So I include this by default in my template. I'd like to spend a little bit more time on graceful shutdown. Skip this, and every deploy or scale down event, you are getting a bunch of errors, aborted connections, stuck database queries, and this may be impacting your users. I prefer to keep graceful shutdown in mind from day one, and I have a little component to deal with it. In short, you register a hook and it runs when the app is stopping. One thing I don't have yet is hook ordering. All hooks run at the same time. For more complex scenarios, for example, if you want to close database only after HTTP server stops, you may want to have ordering. However, many modern database drivers, they already handle it gracefully. In any case, if you need ordering, I already have a ready pattern for it, and might extend the template in the future. All of this is pre-wired. You clone the template, and you have a production-ready patterns and AI-friendly codebase from day one. No infrastructure yak shaving, or things like I'll add telemetry later that never happens. It's there, it works, just move on building features. Production ready from day one, that's my preference. Let's maybe talk a little bit more about AI. The template includes a context folder with a set of prompts in it. And I would be careful here. I would not consider this as a complete system, but rather a set of examples. Every project will have it different, and it should evolve with the project needs and be tailored to a particular AI agent you prefer. I will still do a quick overview of few prompts that I find useful on the most projects. So, firstly, see this commit prompt. It's pretty simple and it will help you to create a nicely formatted commit history. This prompt is the most useful if you then use another one, create pull request, which will use this commit history and, well, prepare a pull request for you. And to be honest, I can hardly remember last time I did this whole part manually. These days I usually commit and pull request with prompts. And few more complex ones that I find the most useful. So firstly, create plan prompt. You can use it to plan for complex developments. And I know, many AI agents, they have a built-in plan mode these days. But I still find a well-crafted prompt quite useful. And once you're done with a plan, you can jump on the implementation using another prompt. Nothing really special here. One thing to mention is that I prefer AI to produce a task completion summary. This sometimes helps later to understand the reasoning. And my favorite one, orchestrate plan. You can use this prompt to coordinate a crew of subagents to implement some complex plan, for example, with dozens of steps or even more. However, it only works if AI agent supports subagents, for example, in Kilocode or Claude. Sadly, Cursor is falling behind here. I've seen some messages that this feature is planned, but at the moment of recording this video, it's not yet there. And I really hope that by the time I publish this video, it is already be available. But currently, when I orchestrate in Cursor, I do it the old way. Well, manually. And here is a prompt to generate HTTP clients from OpenAPI spec that I mentioned. It kind of works, and I think I am more or less happy with it. Let me show you one example that I use in my template that was fully generated with this prompt. This is a pet store API client, a well-known API that many people use as examples and experiments. This client was fully generated with this prompt from this OpenAPI spec. And you can really see that everything seems to be in place. Models, operations, all seems to be good, even unit tests. However, if you have a battle-tested tool that can generate HTTP clients from the spec, personally I would rather stick with the tool instead. The point isn't to copy these prompts exactly. There are a lot of prompts out there. The point is to have a starting place. Build your own collection of prompts that works best for you and your team. I will probably repeat myself. AI agents work best when you give them examples of what you want, not just instructions. So, include examples in your prompts whenever possible or applicable. Once you establish a new pattern, at least extend a relevant AGENTS.md file and mention it. Instructions with examples. That's how you get consistent AI output. If you pick my template or some other template, let's be honest about trade-offs. Specifically, with this template, pros are: production ready from day one, patterns and examples for the most typical backend parts, and AI-friendly setup. Cons are: there is a learning curve to understand patterns and conventions. You are adopting opinionated tooling choices that I made, like Dig, Viper, Cobra, and some other ones. And there is opinionated architecture decisions that lead towards to balanced pragmatism over academic purity. When would I use it? New Go service, moderate size and complexity, and if AI matters. In this case, this template can be a really good starting point for you. I would avoid this if I am building a CLI tool or simple CRUD API that will hardly grow over time. And if you do need performance critical code where nanoseconds matter, well, that's a fully separate story. You will need to drop all the spare parts and layers and get rid of anything that you don't need. But honestly, that's probably not the case most of the time. Here's my take. The Go standard library is great, I love it, but it doesn't give you things like graceful shutdown, config loading, telemetry, or any other things that production services need. You are going to build these patterns anyway, and the question is, do you build them from scratch every time? Or do you build once, refine over time, and then reuse? The point isn't to use my exact template. The point is to have a standard solid base. Use mine, define yours, or adopt something else. But have one, especially if you have microservices. Consistency across services is what makes onboarding faster. It lets you jump between services easily without figuring out, oh, how do I work in this one? How do I prompt AI here? And stuff like that. If you remember one thing, boilerplate is not a technical debt, it's a shared context. A consistent template makes humans faster, makes AI better, and it makes shipping features boring. And boring is good. I'll leave a link on the template in the description. And thanks for watching, and see you in my next video.